Hi, this is Andrew. Thanks for joining me. This video covers the basics of getting started with Python, and it's going to be part of a series of videos about Python. Hopefully, I will go further than in my prior Python series, so follow along. In general, I'm going to be using the material or the direction from the book called Python Crash Course. This is what we use in our scripting class. It is not a sponsored video. They did not give me anything other than they gave me a book several years ago about an earlier version of this book. So to start out, you should install Python. This is where you install Python. There are other development environments, and there are a lot of reasons to use them, but for the purposes of this video, I'm going to start out with just idle, because it is a simple way to see what commands you run and how to make them work. There are online environments, there's PyCharm, there's VS Code, all kinds of ways to do all of this stuff. This is the most simple one, so you see the commands and see what they do, see what kind of problems you can run into. So that's why I'm going to use this for this video. If you have something else you prefer to use, that's fine. You'll be able to follow along and just type the commands into your environment. If you start out with this, you can move on to something more powerful later on. So for now, I have the latest version installed. I have it right here. And in theory, I can type commands right here and just have them work. So we'll get into what variables are in a minute, but if I were to type x equals 3, I can now say print x. And that tells me what is in the value of x. And again, we'll see what variables are. I can see that's 3. And if I want to do y equals x, I'll do times 2. I can now print y, and I will see that I get an answer of 6. So I can do this interactively as I go. But what I really prefer is working from a file, working from a script, a program. And I think especially early on, when you're learning how to do this, this is a good way to get started, because you can see the sequence of commands. There's something to be said for what we have here, but realistically, this is the way I'll do everything with this series, getting started. Now what I have is a file here. And in the background, I have what would be the output of that. So if I go, I just need to set a save location so I can save and run it. So I'm going to do that right now. So now I have a folder called Python Videos. I'm going to save this in the video1 file. So now I have that here. I have video1.py. And I can do the same thing I just did, and I'm not going to get into any comments yet. We'll talk about that later on. But if I do that x equals 3 and then print x, and now I can go up to run, and I can run the module. And it needs to save it first, and when it does, it runs that command and it gives the output down here. And you can see that it's just stored in my iCloud. If you're running it on Windows, everything is exactly the same, just, it looks a little bit different. If you need me to, I can show a Windows example at some point. So just to continue on with what I showed before, y equals x times 2, and I can print y, and I'll explain a little bit about what all this stuff means in a minute. And if I go to run module, it's F5 is the keyboard shortcut. So if I hit F5 and enter, it'll run it. It'll give me the output of x and then the output of y. So that's where we're getting started with things. That's where we're going to see what works. Now I have some PowerPoint slides here. I'll go through and use that as my explanation of what I'm doing, so you can visually see it and hear what I'm saying. And a lot of these, I'll either show examples in PowerPoint, or I will try to put examples into Python. Now, it's a good idea to do it yourself. The muscle memory of typing commands, of seeing things happen, that's really valuable. And pause the video and say, what if I do this? What if I try it this way? What if all that stuff is useful? So let's work on the videos. Now, I said variables, and I didn't explain what they were. I'm going to get rid of all of this and start over on that. A variable is just a place to store things. So if you can imagine it as either a blank piece of paper or more like a mail slot or a box on a wall where you can put something in there, and then you can take it out and change it and put something else in there and just continually update it. You can use that later on. As you saw, I can take that value of X, look at it, multiply it by 2, and assign that to Y. In this case, I'm not using numbers. I'm going to say my message is hello world. And for completeness sake, I should type print hello world. And that's the first time when you're figuring things out, you figure out a new programming language, you do this. You say print hello world. So I can do that right now. I do F5 and I get the results here. I see hello world. So now if I want to assign a variable instead of using print hello world, I can create a message. And the message, this could be, the variable name is message. The variable name could be X. The variable name can be anything you want. In this case, I am using a descriptive name. So instead of hello world, I'll do hello YouTube. And then I close it with a quote. Now if I want to print this out, print message. And now if I F5 and save it, I will get my hello world, but also get a hello YouTube line. Now let's say I go back and I don't want it to say hello YouTube. I want to say hello YouTube. Hello, trying to be creative here. World of YouTube. And now I run it again and I will see hello world from my original line and the new message, because I changed that message, hello world of YouTube. So you can see that we can use variables that way. Now, taking a step back, well, I could do hello world, I'm happy to be here. So by putting it in quotes, we'll see what that means in a few minutes, but that's saying, that's creating a string, that's creating a collection of letters. I'm either putting that into the print statement or I'm assigning that to the message. Now, if I were to put message in quotes, that doesn't actually print out that message that I just created. That prints out the word message. So instead of hello world of YouTube, I will get hello world and then the word message, because that's what I put in quotes. That's what I have here in quotes. So understanding this is, this is step one. So it's really important. Now, moving forward, there are some rules about variable names. And these are some of them. It can only contain letters, numbers, and underscores. And you can only start with a letter. So I couldn't do, let's go back here and fix this and fix this. So now I'm printing out message. I can say this is message 1. I can say this is message underscore 1. But I can't say this is message space 1. If I run this, now I have a syntax problem. It's saying, hey, message space, what is that 1 doing there? So that's its problem, and I can fix that. The other thing I can't do, like I said, is put 1 message. Now I can say print 1 message, and if I do F5, again, it doesn't allow you to start with the 1. So I can get rid of that. I can get rid of that. Now let's say you wanted to have multiple messages. This is where we can either say message 1 or we can do an underscore 1. And now if I do message 1, message underscore 1 without a typo, and I do F5, I get the same thing. Hello world of YouTube. So there are some other, no spaces are allowed. If you want greeting message, you have to type greeting underscore message. You really don't want to use Python keywords and function names, and you don't know what they are yet, but some of them you'll see pretty quickly, print or something like that. Ultimately, they should be descriptive. You should say like this is your account name, not in this example Cisco. You want them easy to type, easy to understand what's there. If you always use X, Y, Z, you don't know what they mean. And one other thing, be careful with the lowercase l, be careful with uppercase O, because like instead of message 1, if I were to do this message L, and then depending on the font, I might not realize that this is also an L. I might not know it's a 1 or an L or an O or an uppercase O or a 0. These things, they're just, be careful with that stuff. So, moving on. There are different types of variables. I mentioned this. We've created string variables so far. Before that, we used numeric values, and there are a couple of different kinds of numbers that we'll look at. A string is just a series of characters. To define a string, you surround it with double quote or single quote. And now, let's say I wanted to, instead of world here, I wanted to put a quote, double quote around world, and you can see how it causes problems there. But I really want my display to have double quotes. That's where I can just throw start and end my string with a single quote, and then I can print out the double quote. And the inverse is true also. I can do that as well. I can say if I wanted single quotes, I could put double quotes around it. So that makes it a string. Now in this example, if I do, let's get rid of some of this and start. If I say I want the length of something to equal 4, and then I print length, I see my number 4, and that's great. But I just created a character, the character that's represented by 4. I can't really do the things with that I might think. If I want to say sides total, let's say area, I'll do length and I will do width equals, I'll do it the same way, 5. And the area of something is length times width. So area equals length times width, and I do print area. And now when I run that, it says you can't multiply by a string, by type string. So that doesn't work, but I can go back and let's say I wanted this to be like this. 4, 5, and now if I were to run this, that is making them actually not strings, that's making them numbers, and special kind of numbers, and we'll come back to that. Now, one more thing I wanted to talk about. Let's say I'm not looking for area, I'm looking for 2 sides, and I go back to having the quotes around length and width, and what I want to do is actually add length and width. Length plus width. And you would think, logically, I expect to see 9 there. So if I run this, my issue is going to be that I have print area, and I actually change my variable to 2 sides. So I need to do 2 sides, and then I can run this, and I expect to get 9, but actually what I get is 45. And what it's doing is it's saying I am taking the 4 and I combine it with the 5 and I add them together as if I'm adding 2 words together. So I get 45. It's only if I make them numbers by getting rid of the single quotes that I then see that I get my number, expected number of 9. So sometimes you can get errors that pop up, sometimes you can get unexpected results, and you really need to be careful with that. So I said numbers. Actually, there are 2 kinds of numbers. There are integers, which are whole numbers, round numbers, 4, 5. There are also floats, which are decimals. And in some programming languages, you have to be really careful with this. With Python, it's forgiving. So if I say 4 and 5.5, and I'll go back to making this area just so we can logically think about what I'm doing. I'll make this area. Now I have an integer, which is my length, and I have a floating point, or a float, which is my width. So I have area, and I run 5, and now I'm not getting what I expect for an area because I didn't change my plus back to a multiply. Now if I run this, I'm multiplying 4 times 5.5, and my answer is 22. Although because it turns the answer into a float, because one of the numbers was a float, it actually gives me 22.0, which is just interesting to make note of. So, moving forward, I can use the print command. I showed you how when we combine two words, I can print a string of them together. And that might be something that comes into play. I'm going to go through that and say I have age equals 23. Clearly not me. My message is going to be equals happy. And then let's say I wanted to say 23. And then I add, actually not 23, happy, age, plus, and then I can put, in this case, cheating a little bit, birthday, and then quotes. And now I can print my message. But you might be able to predict that I'm going to get an error. But actually my error is related to typos. And it's saying, it's even telling me, name age is not defined. Did you mean age? Actually what I meant to do is not put the L there. Now when I run it, I get a different error. And I can only concatenate string, not integer, to a string. So it's saying happy, age, RD birthday can't work. That's where I have this function right here, which turns the age number or the age integer into a string. So if I put str and then I run that, now I actually get my error. I get my answer that I expect. I do happy 23rd birthday. Now I said I cheated a little bit because that RD really doesn't fit if I do anything else. If I do 24, now it's happy 24th birthday, which is, English not good. But moving forward, we can do a bunch of different things, and we'll focus on math and numbers here. We can add numbers, we can subtract numbers, we can multiply, kind of straightforward. Now, division is a little bit different from what you might expect. If you use other programming languages, frequently division is only floor division, where if you divide the first number by the second and eliminate any remainder. In Python, it actually will give you the float of the actual number. So this is where it's a little bit different. So this is what you expect, the regular division. The floor division makes sense. Modulus is really important for a whole bunch of things, and we'll get into that later on. But that just returns the remainder. And you can think if it's Sunday today and you wanted to figure out what day of the week it would be 50 days from now, you can use the modulus. You can use it for time. You can use it for a lot of other functions, including encryption. So, modulus is really important. And here are some examples where I have, and I'm going to type these out so you can see them a little bit easier. But let's get rid of this. I have A equals 9 and B equals 4. Now, if I want to add those numbers, I do add. And that equals A plus B. Then I can go down and do sub, and that equals A minus B. Then I can show multiplication, that's easy, equals A times B. Now, if you notice, I'm doing a mix of having spaces there and not having spaces. It's sloppiness, it's laziness. I'm focused on talking rather than what I'm typing. So, make it look good, making it consistent, but they work. So, div1, let's try typing that again. Div1, and notice I can't have spaces, I can't have anything else. This is going to be a /B, which is division. Let's make it look a little nicer. And div2 equals A divided by B. And this is the floor division. And then we'll do the modulus. A modulus. Let's try that again. We'll put mod in front of that. A modulus B. Now if I want to print out all those results, I can type print, and I'm going to do, actually what I'm going to do is copy and paste a bunch, and maybe make it go a little bit quicker. And what I'm printing are add sub mul div1, div2, and mod. So now when I run this, assuming I'm not missing a mistake, it should print out all of the results of that math. And when I save, I get A plus B, 9 plus 4 is 13, that's correct. 9 minus 4 is 5, that's correct. 9 times 4 is 36, that's what we expect. When we do division, we get regular division gives us 2 1/4, 2.25. Floor division just gives us 2, it wipes out that remainder. And again, so there are times that's really useful. And then the modulus just gives us the 1. So again, there are times that's really useful. So that is kind of the math we can do, arithmetic operators. Now, given all of that, let's try to put it all together. This is a lab that I used in the class, and what I'm going to do is I'm going to work through it. But if you want to pause right now, try working through it on your own. See if you can figure out how to do all of this. Really, there's a big formula there, but that doesn't change a whole lot. So take a break, look at it, and resume. Okay, now that you're back, or if you never left, it was just an awkward silence, what I'm going to do is start typing stuff out. Now, you may have noticed in some of my examples, I had this pound sign where it was a comment, and it was something that was going to explain what was going to run. And that's really useful to put in there. I didn't do that in any of my examples as I was going, but it's useful to have. So, try to do this. Try to put comments in. And this is a program that calculates degrees C when given degrees F. Now, I do have it on screen in front of me, otherwise I would probably type Fahrenheit wrong a dozen times, so that's why I'm doing C and F. So, first thing I want to do, what is it asking for? Create a variable with a temperature in Fahrenheit. I'm going to call that and temp F. You can do uppercase, you can do lowercase. It's really bad form to start. Use lowercase. That's what I'm going to do for now. Temp F. And I'm going to say that what is 70? And then I'm going to say, how do I calculate, let's see. I have create a variable temperature F, use the formula to convert Celsius to Celsius and display a message. So this is doing all of the stuff we looked at before. So I can say temp F equals 70. Now I want temp C equals, and temp C equals, and here we have this big long formula. So I'm going to, and it follows regular math rules. I'm going to do parentheses, temp F minus 32 and then I'm going to multiply that by 5 divided by 9. And it just might not be necessary. I just want to make sure that we're looking at the right thing. Now I can go down and I want to display a result. I'm going to start out kind of simple. I'm going to say, before I go through the whole program, I'm just going to print temp C and see if it works. So if I run it, I can see if there are any error messages, and I get 21.111. I don't know Celsius that well, so I don't know if that's accurate. Was the math accurate? Did it do the right thing? Let's see. If I say my temperature Fahrenheit is 32, that's a temperature that I can translate into Celsius easily because that's freezing. So now when I run that, I get 0. Hey, that's a good sign. So now I'm going to do one more test, and I'm going to say, turn that into 212, because I know that's the boiling point of water. And the boiling point in Celsius is 100. So that makes me trust my calculations. Obviously, I didn't get an error, but I didn't, it gives me a test case. Now, I could always go to Google, and I could say temperature 70 degrees Celsius is whatever in Fahrenheit, and they'll do this calculation also. But this is a way of me testing it out and making sure it works right. So that's not what I asked for in this lab, though. I wanted to say 50 degrees Fahrenheit is 10 degrees Celsius. So I'm going to leave this print line now for now, and then we can deal with it again later on. I'm going to say print, and I'll do my quotes. And actually, I don't want my quotes. I want str, and I want to turn this into a string. This is saying the degrees in Fahrenheit, which is temp F. And then I can add that to a string that says, now notice I'm putting a space in front. It won't just magically do that. So I'm going to do degrees Fahrenheit is, and then I'll close my quote. I'll add my numerical value in Celsius and say str, and this is temp C, and then I can add, and I can go to the rest of my string, which is degrees Celsius, and I'll do a quote, and then I can let's see, let's make this a little bit bigger so we can see all of that. And I need to close my parentheses there. Now, in a lot of programming environments, it will do that on its own. So if I did it right, it'll display exactly or very close to what I have here. So if I run F5, okay, 212 degrees Fahrenheit is 100 degrees Celsius. That's what I wanted there. And I can go back and I can change this back to 70 and run this again. And 70 degrees Fahrenheit is 21.111. There are things we can do, and this is probably not something I'll cover in a video, but you can say, I only want to see 21.1. I don't want to see all of those decimal points. We'll get into that later on if we need to. I can come back and do kind of a follow-up to this video, but we're already a little long. I don't want to keep going a lot longer. So now the other thing is I still have temp C there. I'm still displaying it there, and that's not as clean as I want. So one thing I can do is delete this. But another thing I can do is make it into a comment, and I can say I'm going to save for later or testing value, whatever I want to make a note of. Then it doesn't run that command. So now I can do OK, and all I get is my result here. And again, I can go through my test cases and see if it works and try things out. So that is the first step of doing stuff in Python. You're working with variables and displaying outputs to the screen. Now, obviously, there's a lot more we can do with this. We could say, I want to repeat this program. I want to display, I'm going to copy this. I'm going to go down here. I'm going to paste this, and I'm going to change that value of temp F. I'm going to start at 70, and I'm going to say, what if it were 100 degrees? And now I can run that again, and I can get two answers. 70 is 21, 100 is 37. So now I'm starting to see I can repeat things. Seems a little unnecessary to just copy and paste, and we'll get into that really in our next video. So we'll start playing with having multiple values we can play with. So that's something you should work on. Make sure you can do all of these things, and when you're ready, move on to the next video. That's all I have for you today. Thanks for watching.